Hi, I'm John Paul Raj, and this is part 8 of the complete solution series for May 2025 IB Math AI Paper 1, HL Paper 1, Time Zone 1. Let's roll intro. So, this is question number 8. We're just going to jump straight into that, all right? So, this is a question on functions, as you can see. Consider the function fx is equal to x cubed minus 9x squared plus 23x minus 15 for x in that domain. That's the domain x between 0 and 5. The graph of f of x crosses the x-axis when x equals 1, x equals 5, and x is equal to a. You've got to find that value of a. You can quickly do that on your calculator. This part, you can quickly do it on the calculator. Let's just show how to do that, okay? So I'm just going to quickly jump to my calculator screen. As always, as I've instructed before, we will insert a new problem first, okay, each question. And this is, we need a graph page, so I'm just going to enter a graph page. Enter the function as given in the question, x cubed, and minus 9x squared, minus 9x squared, plus a 23x, and minus 15. I already showed in the earlier question. If you've missed out that part, you can go and check out the playlist. I'll try and link it in the description. How to enter the domain, the restricted domain. Okay, so I'm just going to enter that. This is control, and the conditional keys are here. All the conditions greater than, less than, not equal to, and this is the condition we're looking for, almost like a such that symbol. And there you can enter the domain as it is given here. Okay, so 0 less than or equal to, again you have to go through that menu. Okay, less than or equal to x, again less than or equal to, so control equal to, and then get that less than or equal to, and 5. And the moment you hit that, it should give you the graph only for that specified domain, okay? Find the value of a. Remember, the question says that they're all x-intercepts. It crosses the x-axis at x equals 1, x equals 5, x equals a. And so when you look at the calculator, you can see that that's x equals 1, and 2, 3, 4, 5. That's x equals 5. That should be x equals a, and clearly you can see that a must be equal to 3. Now you can write down that, from the GDC it is clear that, but the IB requires you to sketch the graph as part of the working. The IB requires that, and I'll show you what I mean by that. Okay, so I come back to this. Not sure whether you read these instructions before. So right at the top, and even if you're an HL student who's watching this video, I don't know why an HL student might watch this, not HL, AA student I meant, okay? This is an HL paper, but regardless whether an HL, SL, AA, AI, every math paper will have these instructions right under the the cover page of the exam. This is the first instruction, and let me just go through this instruction because this is what I mean by sketching the graph. It says answers must be written, okay, in the boxes provided. Full marks, I'm interested in this part. Full marks are not necessarily awarded for a correct answer with no working. So if you have given the correct answer and you have just written a equals 3 in this case, full marks are not awarded. As 2 points. My tip would be always keep an eye on the marks. And regardless, get into the habit of this, okay? Because even if your answer is correct and there's no working, IB says, in the question paper itself, it says that you're not going to get full marks, even if the answer is correct. Answers must be supported by working and or explanation. So working is very important. Solutions found from a graphing calculator. So I'm just going to erase this part so that that's clear, okay? Solutions from a graphing display calculator should be supported by suitable working. What is a working then? All right. For example, if graphs are used to find a solution, which is what we're doing in this particular question, you should what? You should sketch these as part of your answer. That is considered as working, and which is why I said in this particular question, you can write using GDC. But how did you use your GDC? That is what the IB is interested in finding out. So that's my examination tip for this particular question, that you need to sketch. I'm not going to sketch, okay? You can, we already did that in the earlier question. Take a good look at the graph and make sure you label all the key points, okay? All the key points meaning, maxima, minima, intercepts, and you can say confidently in your answer, I'm just going to write down what you're supposed to say. You can write down using the GDC. And by the way, as I said, I'm not going to sketch it for you, but I'll just make a hint here, right? Sketch the graph. This is what you have sketched here. That will count as working. Okay, this is color visible. This color is not visible. It's not that visible. It's just cool color. So let's just avoid that. Okay. This sketch that you do here is going to be counted as the working. All right. So using the GDC, you can say that the value of A must be equal to 1, because if you just write the correct answer, you're not going to get those 2 points. All right. Part B next. Using your graphic display calculator, find the area enclosed by the graph of f that we just did and the x-axis for the values of x between 1 and a. So let's get back there, and we're looking at the area between 1 and a. That's the a, right? Between 1 and 3, what is that area? Okay, so it's basically just the integral of this function as given to you from 1 to 3. And they said using the graphic display calculator. That means you could use the calculator option here, you know, the direct what do you call that? Definite integral. Look at me. So I'm just going to insert a calculator page within the same problem. So it's 8.1 is the graph page, and 8.2 is the calculator page. It's dynamically linked. So since you already defined here as f1 of x, here you can just refer to it rather than, you know, entering. You can do if you want to, but I'm just saying that, you know, so go here and get the template for the definite integral, and I can just say you want from 1 to the value of a, which we saw from the calculator, that's 3, and here I can just type in f1, and if the moment I type f1, you can see it comes bold. That's a beautiful thing about this dynamically linked. Okay, definite integral from 1 to 3, f1 of x, so saves you time. You don't have to, you know, write the expression, but in the answer here you have to mention that. Okay, this is using the calculator, and don't forget the dx. The moment you hit that, you just quickly check whether our calculator is set to approximate. Yes, it's set to approximate, and hit enter. Now you should get the area as 4, and even if they have not mentioned, write it as square units, because you know what, you are telling the examiner that I am calculating the area has a unit. So then how do we write the answer? We'll write the answer as required area is the definite integral from 1 to 3. Now don't write f of x. You can you write f of x dx? Well, you can, but I would recommend that, you know, just write down the entire expression. Okay, x cubed minus 9x squared, and then what is that, plus 23x plus a 23x, and what is that term, minus 15, and close that bracket. Do not forget the dx. Okay, every notation counts for, and then you can write, and that is equal to 4 square units. Okay, and then you can write down using GDC here. Okay, using GDC. So the examiner knows that you entered that expression and you got that. All right, so that's 1 A and B, very straightforward. I think the challenge comes in part C. Another function is defined as g of x. Another function g of x is defined like that: negative x squared plus 6x minus 5. The area enclosed by the curve y is equal to f of x, which we just graphed, and the x-axis between 1 and b. Now there's another number called b. A was 3. B is equal to the area enclosed by the second function g of x and the x-axis between that same 1 and b. So basically what are they saying is that, and then I think the question says find the value of b. All right, and the b, they've given you the hint, the value of b is some number between 1 and 3. That is what we're supposed to find out. And do we have enough space? No, we don't have enough space. I already gave you a hint in the earlier parts. Please go and check what I meant by that when there's no space. So I'm going to do it here. Okay, so basically what they're saying is that the integral from 1 to b of fx dx is equal to the integral from 1 to b, the same b. All right, can you see the screen? I'll just adjust that. Okay, of gx dx. Okay, everything is given. X is given, fx is given, gx is given, and you know, the lower limit is given except for the upper limit in both the case. My g looks like a 9. All right, so let's just enter the values now. Okay, so what do we get? This is 1 to b. Fx is that expression, that longish expression we had, x cubed minus, is it a 9x squared? Let me just check whether I got that right. Yeah, minus 9x squared plus a 23x and minus 15. This area apparently is equal to the integral from 1 to b. What is gx? Gx is a negative x squared plus 6x minus 5. Negative x squared plus, is it a plus? Yes, plus 6x minus 5 and a dx. This is, you need to show this, okay? You need to show this. Now, because it's a definite integral and that b is unknown, you can't directly use the calculator, okay? It's going to give you an error. So what they're testing is whether you know how to evaluate a definite integral, even if it's an unknown, meaning upper limit minus lower limit. But first you need to integrate it and then substitute that upper limit minus lower limit, okay? That part you need to show. That is the working, all right? So let's integrate it first. Left-hand side, when you integrate, pardon me, you're going to get x to the power of 4 over 4 minus 9x cubed over 3 plus a 23x over x squared over 2 minus a 15x. That's on the left hand side. Let's just put that vertical bar 1 to b is equal to what's happening on the right hand side. You got a negative x cubed over 3 plus a 6x squared over 2 minus 5x, and again being evaluated between 1 and b. I don't know what's wrong with my throat. Okay, let's simplify this wherever possible. This is 3, this is 3, this on the right hand side you've got 2, and that's 3. Okay, now let's just substitute b, upper limit minus lower limit, values of b. Okay, we are computing for b till the point that you can do the working. You should do the working, showing the algebra. All right, and yes, this looks more like an AA paper till now, you know, but of course you can use the calculator to compute the value of b once you've set up the equation. Okay, so what do we have when you substitute b? So this is going to be b to the power of 4 over 4 minus 3b cubed plus 23b squared over 2 minus a 15b equals, before that equals upper limit minus lower limit, this is the upper limit, just the upper limit, minus 1 to the power of any number should just be 1. So that's just minus 1 over 4 minus 3 plus 23 over 2 minus a 15. This is the lower limit for the left hand side. On the right hand side, the same way, we write it as minus b cubed over 3 plus a 3b square minus 5b. This is the upper limit minus the lower limit minus 1 over 3 plus 3 minus 5. Okay, show this, please show this. All right, please show this working. Show this working. Basically what you're doing is that you've told the examiner that, you know what, I know how to integrate. This step just, you know, communicates to the examiner that you know how to integrate. The second step is basically communicating the examiner that, you know how to evaluate the definite integral, okay, without the calculator, that is upper limit minus lower limit. That's this step. After this, you can enter to the calculator. Now, just to, you know, save the time on the video, because it does take time, okay, and this is another hint, another tip. Please, when you're watching this video or any video, not just this video, pause and, you know, use your calculator. You know, don't just look at marking schemes or, you know, things solved, because it takes time to punch in. And, you know, for the sake of the video not getting too long or boring, I've already entered and calculated. So, but I'll tell you what I did, okay? What I did was I entered this expression as it is, the expression inside the bracket with a negative sign. I entered as it is, and then this term out here on the right hand side with its negative sign, okay, if you were to add it on the left hand side, I combined both to make it one number. Repeat what I just said, okay? So this particular term I evaluated but entered as it is without, you know, adding one by one. I entered the expression as it is, and this term also, but with a positive sign, because when you bring it on the left hand side, there's a positive sign, okay? So I'll show you what I've done, switching to the calculator. Here we go. So this is that term, you can see, okay, 1 over 4 negative 3. Can I just quickly show it here? This is that term with the negative sign, okay? That's that term. And the next term you can see with the positive sign, this term is the term that is, you know, from the right hand side of the positive, so with the positive sign. So coming back to the calculator, I have entered, and then this is the decimal approximation. You can use the decimal if you want to, but I took the fractional expression. I used the fractional expression, so, you know, basically change the settings and going through that. I picked the fractional expression. So after that, you don't need to write it on the examination paper. That's for your reference. How do we solve this? Remember, we're solving for B. I would suggest use your graphing calculator, enter it as a function. But before that, what you'll have to do is that collect all the terms, the like terms on one side. So like terms means all the terms on the on one side and equate it to 0. So that means we'll have b to the power of 4 over 4 minus 3b cubed. There's a b cubed term on the right hand side. Let's bring it here. So that becomes a 3b, not a 3, sorry, it's a b cube over 3 plus b cube over 3, and then there's a 23 b square over 2, and there is a negative 3b square term from the right hand side, and then the left hand side you have a negative 15b, right hand side you have a 5b, so it becomes a positive b, and this term, remember, we've already evaluated, leave it as a fraction with a positive sign, plus a 47 over 12 equal to 0. It's a long string. I hope this is visible. That's the entire equation. And again, I'm not going to simplify, okay? As an AI student, you just have to show that you know what you're doing. This entire expression enter in the graph page. And what we'll do is that we'll find the root as a new function, okay? Enter this as a new function. And remember, when you enter it on the graph page on the TI-Spy, you can't enter it as a b. You're solving for b. You enter the x, okay? Find the root, the x-intercept, because it's equal to 0. That should be a solution. So you can then say, using GDC, and by the way, do you have to graph it? Because remember the tip that I showed you earlier? Yes, the answer is yes. You've got to sketch the graph, and then you can say, you know, using the GDC, the x-intercept of that graph is. So I've already entered that graph already, just to save time on the video, but to use the time to explain what's going on. Can you see that's a longish expression, and that's the graph. They gave the hint in the question that the value of b that you're looking for is between 1 and a, then number 3. Okay, so you can see this is 1, that's 2, and that's 3. So that's the x-intercept. Make that sketch. That's part of the working. Part of the working I already explained. Make that sketch. Okay, that's the tip for this particular video. Every time you use the graphing calculator, you're using the graph. Sketch that. That is equally part of the working. Don't just write using GDC. So if I find the x-intercept, go through menu, analyze graph, and find the 0 or the x-intercept. That's the x-intercept we're looking for. That's 2.57. 2.57. And so we come back to our paper and say, using the GDC, and make sure that you sketch. I'm going to write that thing again. Sketch the graph. That counts for working. So using the GDC, it's clear that b must be equal to what? 2.57. All right then, so that's all the time that we have for this particular video. If you found something useful, please make sure that you like, share, and subscribe to this channel. If you visit my channel, you'll find several other videos on my channel. Do check them out. And if you have any questions, a concept, a topic that you'd like to be explained, do mention that in the comments, and I will make a video for you. I'll see you all in the next one.